All right, welcome back. We're going to do a handful of videos here, just sort of overviewing Chapter 5. We're doing Chapter 5, which is a decimals section. Tons and tons of detail, so we're sort of doing it as a review or an overview, depending on how you want to think about it. Decimals, of course, just another way to write numbers that are not whole numbers, right? Numbers that are sort of between whole numbers. We have the fraction system, sort of breaking everything up into a pizza pie, and I guess we'll just leave that in. Breaking everything up into pieces, pieces of pizza pie, and another way to sort of think of this is to essentially just sort of continue with place values, and you get decimals. So let me sort of write out just an example decimal number, right? 52,361 point. So the decimal, of course, has a decimal point, which is like a period. We'll do 4897. So this is our decimal number. And what we're going to do here, right, is we're just going to label all the different place values. The sort of way that we label this and how we sort of talk about it actually tells us a lot about the sort of values here, and actually also syncs up pretty nicely with the conversion into fractions. So let me show you what I mean, right? So our 1 here, by coincidence, a little bit is in the ones place. So our first digit above the decimal place, the sort of first whole number digit, is the ones place. That means any of the numbers in there count for what they have, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 all sort of count for that much. They sort of count for 1 unit each. 6 is in the tens place, right? So then your second place value is essentially 10 times as much as the previous one, right? So this is the tens place. So the 6 here really is like a 60. This is sort of a 60 and a 1. 60 plus 1 is 61. Moving up, 3 is going to be in the hundreds. Our 2 here is in the thousands. And then the 5 would be in the 10,000s. So the idea here, right, is obviously as you sort of go, you get bigger, 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 100,000s, millions, 10 millions, 100 millions, billions, 10 millions, 100 billions, trillions, and so on and so forth. They sort of go in threes as we get up. And what we do with our whole number values is they get bigger, bigger. Right, we put the sort of comma in to help break up the number and make it a little bit easier visually to sort of figure out how big your digit is. Some, like non-US number notation, sometimes what other number systems do is they actually use a comma in the decimal position here. So if you see that in like a French notation, for example, it can look a little different, it can look a little confusing, but we're sort of doing this from the US perspective. So the decimal point is a period and not a comma. So right in the hundreds place, you're sort of worth 100 times that amount. 10,000s, you're 10,000s times that, right? The 5 here really is worth 50,000, and sort of so on and so forth. What happens here then if we go, you could almost do this, right? I mean, 1s is sort of times 1, 10s is times 10, hundreds is sort of times 100, right? This is kind of what we've got. As we go to our decimal place values, so these are still positive values. They have value, they're just less than one whole unit. And so the first place value here for our decimals, where the 4 is, this is going to be what we call the tenths. So like tens, but with a th, right? Tenths. You might say to yourself, hey, that sounds kind of like a fraction, right? 1/10. 4 tenths, that would be 4 over 10, and we'll sort of come back to this idea, but that is exactly what it stands for. So tenths here means, right, syncs up with sort of our 1/10 fraction. You could think of it that, or also in some sense it's like a 4 divided by 10, right? We're sort of dividing by 10 instead of multiplying by 10. We don't have a onths place. If we divided by 1 or multiplied by 1 over 1, right, we would just have ones again. It wouldn't really make sense. So the first decimal place is tenths, and then what will happen is we'll sort of keep our same name convention going. So hundredths, just that all the decimal places have this th, right? So this is, excuse me, with 1 over 100. This would obviously be thousandths. th times 1 over 1,000. I maybe should have spread these out a little bit more. 10 thousandths th times, right, 1 over 10,000. And you're going to notice here I essentially even these out, kind of 5 to the left, 5 to the right. The last place value here is actually down in the decimal place to the 100 thousandths th. So times 1 over 100,000, or dividing by 100,000. So as you get to sort of these decimal numbers, they're worth smaller and smaller and smaller values. What this kind of leads us into is how we would do a conversion between a decimal number and a fraction, converting in particular a decimal into a fraction. And it actually is going to come directly from this naming conventions. So let me sort of give you an example, and we'll sort of go through how we would maybe say this number and how we would then kind of name it. So you might sort of just say 6.15. That's a perfectly reasonable way to just describe the number. Technically, what you would say if you wanted to be sort of extremely proper is you would say 6 and, so 15, right? 1/5 is 15. It ends in the second decimal, so that's hundredths. So this is 6 and 15 hundredths, th. And the idea here is that let me just check the focus on this. Hang on 1 second. The light is a little low. Hope you guys can see okay. So 6 and 15 hundredths, right? The idea here is you've got, literally the number 15 in your decimals, and it ends in the hundredths place. So you say 15 hundredths. And so what does this turn into? Well, what it converts into is, 6 is 6. 15 hundredths would be 15 over 100. So it syncs up pretty nicely with the name, right? Hundredths would be as a fraction, 1 over 100. So if you said 6 and 15 hundredths, right, you would sort of immediately, hopefully, think of the fraction 15 over 100. And then from here, all we need to do is reduce. So what will happen is we'll sort of get an initial value, and then we'll just sort of reduce it down. In this case, right, this would be sort of 3 times 5 and 5 times 20. So the 5s go, so this would be 6 and 3 over 20. So the reduced version is our goal. We'd like to get this sort of final reduced answer. Obviously, 15 over 100, I mean, that is a fraction. That exists. It counts. But we'd like a reduced version as our sort of final answer. One of the things here that will happen, we'll put another example sort of up as we talk through it, is then all of our denominators, as we do this conversion, are going to be powers of 10, right? 10, 100, 1,000, 10,000, a million, 10 million, right? And so that actually helps simplify what we're going to look for when we reduce, because when we reduce something at the power of 10, we're really only looking for 2s and 5s. Let's say we have something in a point, 0, I don't know, 8.4 or something, right? And the first thing, let's just sort of get this rewritten. Whole number is 0, so this is going to be purely a fraction. This would be 84 So tenths, hundredths, thousandths. So this would be 84 thousandths. So that would be 84 over 1,000. Right, one thing here, it might be tempting to just sort of write it as 84 over 100. I think the temptation sometimes is just to sort of put another place value on there. If you've got 2 above, you should have 3 below. But this is actually, 0.084 is even smaller than 0.84. 0.84 would be 84 over 100. This is 0.084, so in some sense there are 3 place values here, which syncs with 3 zeros on the bottom. As far as reducing it goes, I'm going to look for 2s and 5s. I don't have any. 5s, this would just be kind of 42 times 2. 1,000 would be 2 times 500. 2's go out. 42 over 500, well, that's going to be 21 times 2. 250 times 2, so 2 cancels 2. And that's about that, right? 21 is not divisible by 5, and it's not an even number anymore. So this guy's going to reduce down to 21 over 250, and that would sort of be our final answer. You might have something that doesn't reduce. I guess I could do kind of one of those just quickly. Also, things, positive versus negative is not going to have any real impact on your final answer, right? A positive will be a positive as a fraction, a negative will be a negative as a fraction. Positive or negative, they just sort of are what they are. If you get something that doesn't reduce, let's say you've got negative 19.79 or something, right? Well, okay, I mean, even though that maybe seems like it's not going to be a great number, it actually, in some sense, is even faster to reduce. This is just going to be negative 19 is your whole number. This is 79, right? Hundredths. TH. So 19 and 79 over 100. 79 is not divisible by 5. It's not divisible by 2. So that's going to be our final there. And that's the basics of it. So doing these conversions really come directly out of the names of the numbers. And the trick is just to reduce to lowest terms once we get the initial sort of rewriting done.